Hello everyone, welcome to another video in the Predicting with MindsDB series. In this video, we will be predicting the quality of water using MindsDB. So let's get started. In order to complete this tutorial, we will be using MindsDB Cloud. So if you don't have an account, you can check my video on how you can sign up. The link to the video is in the description. So once you have signed up and logged into your account, you will land up in the MindsDB dashboard, which looks something like this. So here there are three main parts. The top one is the query editor where we can write the queries, and the bottom panel displays the results, and towards the right we have the learning hub resources which you can use to learn more about MindsDB. So the first thing we want to do is import a dataset. So I am using a publicly available dataset from Kaggle, which is this one, the water quality dataset. The link to download this dataset is already available in the description. You can download the dataset from there. I have already downloaded it and it is available in my local machine. So what I will do now is I will go over to this dashboard. I will click on add data. So as you can see, MindsDB supports a wide variety of database integrations, but for now we will click on files, then we will click on import file, and then in the import a file I will click and I will select this water potability CSV file. I will say open. Then here for the table name I will keep it as water and I will say save and continue. So the file has been uploaded now and we have two sample queries here. The first one will list out the table so that we can check whether the table is present or not, and the next one will list out the data records from the table. So let us execute them one by one. So here we have the table water present already, and then let us fetch few records, and here we are able to fetch the data records from the table water. So we are good to go with this one. So the next thing we want to do is create a predictor model. So MindsDB by default provides us with a create predictor statement, which is similar to a SQL kind of query. So the statement will look something like this. Say create predictor followed by MindsDB dot name of the predictor. You can give it anything. I'll say water predictor. Then we will say from which database where the table is present. So it will be from files. Then I'll say select star, like what all columns from this table you want to feed into the model. So I want to feed each and every column. So I'll say select star from name of the table, which is water, then limit 10,000. So in case you don't have a free trial, then we are limiting the rows to 10,000, as without a premium subscription you will not be able to feed more than 10,000 rows and the query will error out. So to check that, we are using this limit. So it is select star from water limit 10,000 followed by what we want to predict. I'll say predict, and here in this table if you'll look, this thing, the potability, so this is the thing we want to predict. So when the potability is 0, so the water is not feasible for humans to drink. Okay, and when the potability is 1, the water is said to be feasible to drink. So this is a binary data value. It will return either 0 or 1. So we will say predict potability and put a semicolon at the end. Now we'll hit run. So it says that query is successfully completed, but the predictor model takes a while to train and do the predictions. So in the meanwhile we can check the status. So the query will look something like this: select status from MindsDB dot predictors. So each and every predictor model that we train, it stays inside the predictors table as an individual row record. So then what we want to do, we want to say where name equals name of the predictor model, which is water predictor, So I'll copy it and I'll paste it here and we'll give a semicolon and then we'll run this one. So the current status is training. So you can expect three kinds of status for a model. The first one is generating, then it is training, and when the model is ready to do the predictions, you will get the status as complete. So now we have to wait till the status turns into complete. Okay, so as you can see, the status is complete now. So the predictor model is ready to do the predictions. But before we jump to that part, let us try to understand a few details about the predictor that we just created. So MindsDB by default provides three kinds of describe statements that can provide three kinds of details about the predictor. So we will execute them one by one and fetch those details. So the first one is describe by features. So I will say describe MindsDB dot name of the predictor, which is water predictor dot features. So it will give you the list of all the encoders that are used on each of these columns and will also let you know the role that each column plays for the predictor model. So let us execute this one. So as you can see, this is the list of all the columns that are present in the table, and this is the type of data they store, and these are the type of encoders that are used on them, and finally this is the role that they play for the predictor. So let me increase the size, and here as you can see we are predicting the portability. So this is the target value, so it serves as the target role, and rest everything is the feature set. So the next thing that we want to do is describe it by model. So I'll copy this statement now and I will paste it below, and I will change the features to model. So what this statement does is that it provides you with the list of all the underlying candidate models that were used while training, and also you will be able to know which candidate model had the best performance, and that will be chosen for this predictor. So let us execute this one. So as you can see, these are the two underlying candidate models that were available, and the performance of light GBM is higher than that of neural. So that's why this one is selected, and we have 1 at the selected column, and for neural it is set at 0. So the third one will be the describe by ensemble. So I will change this one to ensemble. So what this query will do is that it will give you back a JSON output that will contain the different parameters that enabled to determine the best candidate model for this predictor. So let us execute this one. So as I said, this is the JSON output, and it has the list of each and every parameter which helped to determine the best candidate model. So that's all the details we can find about the predictors. So now it's time to do the predictions. So as we are predicting the water portability or the water quality, it is recommended that we use the values for all the feature sets to have a more accurate prediction. But for a start, we can provide the values of few feature parameters and then we will try to predict. And finally, we will give the values of all the feature parameters and we will try to predict once again. So now I will say select portability, comma, portability explain. So this portability explain column will hold the JSON output of the predicted value and the confidence value, the truth and null values, and also the confidence classes. So these are the two rows we want to display. Then I will say from MindsDB dot name of the predictor model, which is water predictor. So I'll copy it and I'll paste it here. Then we want to provide the values of the feature parameters. So I'll say where pH equals 2.6 and hardness equals 210 and solids equals 18645 dot 233 and chloramines equals 6.546. Then we'll put a semicolon and we will execute this one. So as you can see, the potability is 0, which means this water is not suitable for human consumption. And in the potability explain, we have the value of the prediction and the confidence. So the model is 86.74% confident. There is no anomaly, there is no truth, and also we have the probability classes. So now let us go for a prediction with the values of all the feature parameters. So what I will do now is I will copy this query and I will paste it below, and we will keep adding the other available feature parameters. So I will say chloramines, and then after that what we want to do is sulfate equals null and conductivity equals 467.5 and organic carbon equals 9.98 and trihalomethanes equals 89.68 and turbidity equals 4.99. So these are all the feature parameters, and we have provided the value for those. Now also let us change the value of the first 4 that we just copied from above. So for the pH value, what we will do is we will change it to 6.9, and for the hardness we will say it is 201. For solids, let us say it is 11,350.675, and for chloramines we will say 4.3. So now we have changed the values, and also we have added the left out feature parameter values as well. So now let us execute this one. Okay, so now the potability value is 1, which means this water is suitable for human consumption. And also in the potability explain, you can see the value of the prediction and the confidence value, which is 84.33, and then the anomaly, truth and null, and the probability classes. So that's how we were successfully able to predict the water quality using MindsDB. That's all for this video. I hope you had a great time watching this one. So drop a like, subscribe to the channel, and do share it with your friends. And before you leave, drop a GitHub star on MindsDB GitHub repository. Thanks for watching this video, and I'll see you in the next one.